Okay, so our last major subtopic for the summer course is free fall. This isn't entirely a new topic because it's related to acceleration. So, when something falls, what makes it fall? Hopefully you are recognizing that this is going to be related to gravity, and gravity is a specific kind of acceleration. All right? Gravity is a constant value. It always exists. It never goes away. All right? And it always exists at the same amount, no matter where you are on the Earth. Okay? That's slightly untrue, but we'll talk about that more when we get into forces. But it changes so minimally that we say that gravity is a constant value of 9.8 meters per second squared. This is the value you will always use in class, so get used to this number. And keep in mind that gravity is an acceleration. All right? So let's talk about how to apply this to our acceleration. So the really kind of new important stuff from here that is going to be key to kind of figuring out or applying acceleration and gravity is on this slide. These 4 reminders, rules, are things that are going to come in very handy when trying to solve for problems. All right? So again, gravity is an acceleration which has a direction, all right, which impacts how it applies to things. And let's think about that. What direction does gravity have? Right? Where does gravity make you fall? Hopefully you are thinking downwards. Okay? So gravity always goes down. Now, you can have an object moving upwards, like you throw a ball up into the air, or you can have an object falling down, moving downwards with gravity. All right? So let's think about that. If the velocity of the object is going down, all right? So these 2 vectors point in the same direction. Should they work together or work against each other? Right? Hopefully you're thinking that because they point in the same direction, they're going to work together, they get added together, that sort of thing. Whenever you have an object that is falling downwards, gravity works with the velocity of that object, which means it's going to be a positive acceleration, or it will cause an increase in speed or velocity. Okay? Now, if you think about the opposite situation, say you throw an object up in the air. Right? So the object has a velocity upwards. Gravity will still always be downwards. All right? So now those are moving in opposite directions. Are those vectors going to work with each other or against each other? So if you think about it that way, in this case, if you have an object going up, all right, then acceleration due to gravity actually works contrary to the velocity. So you want to use a negative 9.8 meters per second squared. Okay? Which means that, and this should make logical sense, if you throw something up in the air, does it speed up or slow down? It should slow down, all right? Because a negative acceleration always causes a decrease in velocity. All right? This first idea here, probably one of the most important ones, okay? Another thing to think about is as you throw an object into the air, does it continue going up forever and ever, or does it stop and come back down? All right? So hopefully you recognize that on Earth, whenever you throw something up in there, it does come back down, which means at some point it has to stop. All right? So at the very, very top of any object that's thrown up in the air, the velocity is 0. Okay? When it reaches the very, very top, the velocity slows completely to 0, and then it turns around and starts speeding up. Okay? Some other conceptual things, and as long as we're ignoring air resistance, actually even with air resistance it doesn't matter, but if an object leaves your hand with a certain speed, so say you throw an object into the air 5 meters per second, when it comes back to your hand at that same level that it started at, it returns to your hand with the same speed. Okay? So if you think about, say, it starts with 4 meters per second. When it gets back down, it'll still be moving at 4 meters per second. However, at the top, what happens to it? Hopefully you're saying stop, and that's going to be a 0 up at the top. Okay? Same this also applies, there's also something related to distance. The time this also relates to time, because gravity is constant, the time it takes to change from 4 meters per second to 0 meters per second is equal to the time it takes to change from 0 meters per second back to 4. All right, so the time up, so say it takes 2 seconds to reach the top. Now this does not match at all math-wise. It's going to take 2 seconds to fall back down. Okay? So speed it leaves with is the same speed that it returns with. Time it takes to reach the top is the same as the time it takes to fall back down. Okay? These two help when you're dealing with a period of time where you're moving with a positive acceleration and a period of time when you're moving with a negative acceleration. This way you can split things up. All right? But let's get some practice with this. So, equations for free fall are the same equations as acceleration, because what is gravity? An acceleration. All right? Just a few quick examples to go through. Say a rock is dropped from a cliff and falls for 25 seconds before hitting the ground. How high is the cliff? All right, so if you think about it, we know that time is 25 seconds, and even though it's not written, all right, do we know what acceleration is? Yes. Acceleration, typically, if it's regarding free fall, it will not be written out for you. You have to remember that it's 9.8 and then make the decision of whether or not it's positive or negative. All right, since we're falling, should it be positive or negative? Is the speed going to increase or decrease? Hopefully you're saying positive because speed will increase. All right, and then we want to know how tall the cliff is. All right, so that's going to come from our equation that is x equals VO plus 1/2 AT squared. If you drop an object from the top of something, what velocity does it start with? Just kind of thinking logically about this. Hopefully you're thinking, oh, if I'm dropping something, I'm holding it still before it falls. So my initial velocity is going to be 0. Okay? So if we substitute what we know, we're going to have our x equals 1/2 times 9.8 times 25 squared. All right, so if we plug that in, 4.9 times 25 squared, that would have been a probably unrealistically tall cliff, but it's 3,062.5 meters high. All right, units were meters. So let's try another one. At another cliff, you throw a rock down with an initial velocity of 5 meters per second. If the rock reaches the ground in 25 seconds, how tall was the cliff? So this is the same type of problem as what we just had. All right, we know time is 25 meters per second. So this time we know our initial velocity is 5 meters per second. Okay, and oh, I'm sorry, I left off part of the equation on the last slide. And just like the last problem, our acceleration is 9.8 meters per second squared. All right, so if I write out my equation correctly this time, x equals VOT plus 1/2 AT squared, our substitution will look this way. Let's see, 5 times 25 plus 1/2 times 9.8 times 25 squared. That's going to give us an answer this time of 3,187.5 meters. Okay. All right, last example. This one's a little bit more complicated. We have a ball that is thrown upwards with an initial velocity of 20 meters per second. How high does the ball travel? All right, so we know that we have initial velocity of 20 meters per second. We know we're going upwards, which means what about our acceleration? All right, think about it. Do things slow down as they go up or speed up? Hopefully you're saying slow down, which means we need negative acceleration. All right, and then our question is our distance. So if you think about our equations, the one that has this information, let's see, we have one that involves time and one that involves final velocity. All right, so are we given time? Hopefully you're saying no. Do we happen to know our final velocity? All right, our ball is going to go up and come back down. All right, it's going to leave with a velocity of 20 meters per second. And it's going to come back down and have a velocity of 20 meters per second. All right, but what happens up here? You remember from our rules, your velocity has to reach 0 before it can turn around and come back down. All right, so another known that we have is our final velocity is 0 meters per second. All right, so if we have this equation then that we can utilize. V squared equals v initial velocity squared plus 2 times acceleration times x. If we want to solve for x, that looks like v squared minus vo squared over 2a. If we substitute, we're going to have 0 squared minus 20 squared over 2 times negative 9.8. Does it look like our negatives are going to cancel out? Hopefully you are saying yes. So we have negative 400 divided by 2 times negative 9.8. And that gives us 20.41. And then our units, we were solving for distance, right? So that is going to be 20.41 meters, right? So if you really got acceleration, this is probably enough for you to get through the stuff, but especially if you struggled with acceleration or you're having issues with that 4 rules, go through the rest of the additional resources to help you with this.